Hello everybody. This video is about decision tree regression in notebook. So let's load the data. To load the data we need to import pandas library. So import pandas spd, and then we need to read the data. Set. So I call my object my data equal pd.read underscore csv. The data is found in this folder. So the lake data here, so this is the directory. I'm going to type slt docs, so it's in E, sltech docs, the backslashes data, the backslashes lake.csv. So the data is read. Let's see what is in it. My data dot describe gives us the statistics. This is what you have: evapotranspiration, specific humidity, air temperature, soil temperature, precipitation, soil moisture, and the lake level. So we have a lake level as our output feature, and the other features are the input. So next step is going to prepare the input and the output feature. So let's have our input features. Let's call x equal, have my data. Here we need to drop t, it's time, and also lake level, which is our output feature. Put brackets here, and then we take the axis equal 1. So let's excuse me, see the shape of x. You have 240 observations and 6 variables. Let's print x and c. Maybe let's take the first 10. observations. So this is what you have. Okay, now you are going to split the dataset into training and testing dataset. For this we need to excuse me, to import the function train test split from scikit-learn model selection. Then splitting the data itself. So we have X train, X test, Y train, Y test equal train test split. We have our X or Y and the test size excuse me, equal 20%. Let's see the shapes of the split data. X train dot shape, X test dot shape, Y train dot shape, Y test dot shape. So 192 observation for the training data for X and 48 for the testing data, and for Y we have 192 and 48. Okay. Excuse me. So next step is to have our model with the decision tree regression model. For this we need to import the regressor. From scikit-learn.tree we import the decision tree regressor. The next step is to create and fit the model. So let's call the model light level decision tree. So we have a decision tree regressor dot fit x train y train. So let's see the coefficient of determination, the model. So let's print the training square is, let's take 2 decimals. Weight level underscore dt dot score underscore over x train y train. Train y train. So the train as r square is 1. Okay, so let's evaluate the model. If it's n, it means that all the metrics such as MSC is going to be 0. So let's start with the mean absolute error. Say model have training model evaluation. So we need to import the matrix. Let's have the mean absolute error. The mean squared error. The explained variance score. Explained. So explained variance score. Let's have our R2 score here also. Import it. So these are the metrics we need. So to have the mean square, the root mean square error, we need the mean square error, and to have them, we need how to predict on the training. That what I'm going to do here is to predict and then compute the mean absolute error, the mean square error, and then have also the explained variance error. So we first predict on the training. Normally we should predict on the testing, but let's do also on the training to have all its metrics we need. So let's say y train underscore pred equal weight level underscore dt dot predict, and we predict on x train. you already have the R square here using this function dot score, but we can have the same thing here using the R2 score also. But this time, instead of you having X train and Y train, you are going to have the Y train pred, Y train and Y train pred. So let's try. It's the same thing, but just different ways of getting the same thing. So print how to score this time. This is the function we'll use. R2 score, and this time it's going to be on Y train and Y train pred. So we notice here functions, different functions. Here score, here R2 score, and then you have X train, Y train, here the Y train and Y train pred. And then we get exactly the same thing. So now the mean absolute error, print the mean absolute error is Y train, Y train pred. The predicted, the observed and the predicted lake level 0. The MSC is going to be the same thing because you have 100% as R squared. So print the MSC is absolute mean squared. Sorry. Y train pred, predicted observed. And the root mean square error SPRT mean squared error Y train pred. Here we need to import numpy as np. Because we use an np here, this function. Sorry, I have typo here. Okay, and then we'll have our explained variance score for EVS print the EVS is explain variance score separated by underscore observed and predicted lake level. So it's one. So now we are going to predict on the text, the testing data, and have the metrics as well as some plots, the prediction error, the results plots, as well as the observed and the predicted. So prediction on the testing data. So let's call by test head equal our model dot predict on X test. So let's print the equation of determination R squared and the testing R squared is let's take 2 decimals. Use the function up to score. So y test and y test spread. So it's equal 43%. Or we can have it using the dot score, the same R squared using the function score. So our model dt not score this time is going to be on X test and Y test. Okay, here we have a T missing here. Okay, so I get something, some result using the two different function R to score and just score. Okay, so now we are going to plot the predicted and observed on the testing sample data. So we need the matplot, lib.pyplot as plt function, matplot nobody sent us from, sorry, should be import instead of from. Matplot lib.pyplot, matplot lib.pyplot. I'm missing 4 here. Good. Now we need to set the boundaries and the parameters of the plot. So we need our figure size, plt dot rc params figure dot fixed size equal, sorry, let's say you have 10, stake 10 and 6. And we have our range, SAX equal range. The range is going to be the length of X test. And then now we are going to plot plt.plot. We need to plot observe, so y test, the label equal to observed, the color, let's take K, the line width, line style, sorry, it's a line, so this is what you have, the observe, lake level, to test data, and then we plot the predicted. The predicted we call it y test spread, and the label predicted. And the color is the same, but this time instead of having a line, we'll have the dashes. So line style, so the predicted and for line, the observed are presented in dashes here, the dash line. Now you are going to put the labels on y and x axis. plt.y label, this is lake level in meter, and plt.x label, let's say testing sample data. So let's see our labels. Yep, lake level and the testing sample data. So now we are going to put the legend, plt.legend, the boundary box to anchor equal, let's x 0.5 and y negative 0.2 to balance it. Location, we are going to put it to the lower center. The legend is going to be in the lower center of our plot, and we don't want to have a frame around the legend, so frame on equal false. And we want to have the symbol of the observed and the predicted side by side. So let's say number of columns equal 2. So one column for the observed, the second column is for the predicted. So let's check. So here we have here observed, predicted. This is lower center of our plot, and we have the two columns here, and around the legend we don't have the frame, so because we set it to false. So what else do you need to do? Probably show is already shown, so plt.show. So this is the plot of the predicted and observed lake level and the testing sample data. So the next step is to plot the prediction errors and the residuals. To do this, you need to go to command prompt or anaconda prompt. And the type pip install yellow brick. So let me write here using yellow brick. Plotting the prediction errors and the residuals using yellow brick. So I need pip install yellowbrick, type das in the command prompt or Anaconda prompt. Then you come to Jupyter Notebook and you continue your work. So here we have the prediction error plot. We need to import prediction error from yellowbrick.regressor. Then we need to create our visualizer equal prediction error of our model, which is LLDT. LL_DT. So, and then we need to fit the visualizer on X train and Y train. Then we need to have the scores of the visualizer on the testing data, which are X test and Y test. And then we need to show it. So visualizer dot of. So this is the best fit. We have the identity and then we have the testing R square. This is the prediction error plot. On the y-axis you have the predicted values of lake level, and the x-axis you have the observed, the y. So here we have the residual plots. We need to import residual plot from yellowbrick.regressor. Yellowbrick. From yellowbrick.regressor import residuals plot. Then we have our visualizer, which is residual plots of our model, lake level underscore decision tree, and we fit this visualizer on the X train and Y train. And we have the score on the testing on X test and Y test. T is missing here. And then So here we have the residual plots for decision tree. You have the training R square equal 1, the testing R square equal 0.42. Have the residuals here on the y-axis. We have the distribution here and the predicted values. The last column presents here the distribution. So now we are going to evaluate our model. Testing model evaluation. You cannot evaluate the model before plotting the predicted versus the predicted and observed, as well as the prediction errors and the residuals. So let's have our mean absolute error. Y-test spread. The predicted and the observed. Sorry, I messed up here with the dog. I'm sorry. Okay, the mean absolute error is equal 0.28. I'm sorry, dog is barking, so I'm so sorry for that. Okay, so that's how you got the mean absolute error. And now let's have the mean square error. The MSE is predicted, observed, sorry, and the predicted. .28 for mean absolute error, 0.14 for the mean square error. Let's see the root mean square error. The RMSE is np.sqrt mean squared error of y-test and y-test spread. .37 and the ESV, the explain variance score. The EVS is take two decimals as well. Explained variance error of y-test and y-test spread. Y-test spread. What's wrong here? Explained variance. The ESV is okay. Explained variance error y-test request. Explained variance error is not defined. Explained variance error. I import it. Oh, sorry. Explain variance score. Oh, I'm so sorry. Explain variance score. Explain variance error. Sorry, so sorry again. The dog is barking. So okay, this is what you get for the explain variance score. Then we are going to run the cross validation, the k-fold cross validation. K-fold cross validation. We are going to use cross val score. So from scikit-learn model selection, import cross underscore val underscore cross val score. So cross validation on training dataset. So let's say the score on train equal cross underscore val underscore score cross val score. We have our model rel underscore gt. We have x train. We have y train. You take the scoring as the mean square error. This is what we need. So sorry. Back, the dogs are still barking. And the cross validation, the number of faults 10. But with this mean square error, we are going to have an error message, and it tells us here at the end, mean square error is not a valid scoring value. Use sorted scikit-learn matrix to get the scorer.key to get valid options. So to solve the problem here, I found out that we need to put negative here at the beginning of this scoring. So you put negative underscore mean score error, and we are fine. So let's see our score on train. This is what we get for the 10 folds, the error corresponding to each of the folds. So let's have the mean of it. So score train equal np dot mean of score train. So we will certainly have a negative value. So let's have our score train. So negative 0.17, and we need to make it positive. So to make it positive, we need to bring absolute, to take the absolute value. So from NumPy we need to import absolute. And then now we take score train equal absolute of score train. Let's output our score train, and we have it here, positive now. So let's deal with the same thing on the testing data. Have the cross validation on the testing data. Let's call it score test equal cross val score. You have our model, you have X test, you have Y test, you have the scoring equal. This time you take the negative, mean square, error, and the cross validation, the number of folds for the cross validation equal 10. Score test is going. And take the mean. The mean score. Output score test here. So here you have the mean, it's still negative, and we know that you already have we already used the absolute here in the score train to transform it into positive, to take the absolute value. We can do that here as well. So we just put absolute here. Sorry. It is going to give us positive value. It's here, 0.14. So we see the cross validation MSC 0.17 on the testing, almost 0.18 here, and 0.14 on the testing, almost 0.15. So 0.14 on the testing data and 0.15 on the training data set. So I hope this video will help you in doing your research or manipulating your data for any kind of work you are doing. So thank you very much for watching. See you next time for another video. Thanks.